Okay, so today we're going to cover section 4 and we're going to learn how to use geometric probability. So probability is the likelihood that an event will occur. It's a number between 0 and 1. It can be written as a fraction, a decimal, or a percent. Probability of an event A could be written as P, and then they put the A in parentheses. Here is like a number line. So again, probability is a number between 0 and 1. When you say that your probability is 0, that means that it's impossible. It's not going to happen. If the probability equals 1 or 100%, then it's for sure that it's going to happen. If it's in the middle and it's 0.5 or 50%, then it's equally likely to occur or not to occur. So 100% or 1 is certain, and then over here this would be 0%. Again, you can also write them as decimals, which are on the number line. And you can also write them as fractions. So this would be 1/2, 1 over 1, or 1 whole, and then here this is just 0. This would be 3/4. This would be 1/4. If you write it as a fraction, 25%, 75%. So if you might have covered simple probability in middle school. A lot of common ones would be flipping a coin or rolling a number cube, which is a dice. So for example, this whole terminology here of PA, so like for example, in the case of rolling the number cube, if I said, what's the probability of rolling a 6? Remember, you would take how many 6s occur on a dice, and that's 1 over the total numbers. We're going to be doing the same thing, but now with shapes. That's why it's geometric. So we're going to be putting the area of what we're aiming for over the total area of the whole figure. So we're going to see that coming up. So here, this is also more of the definition. Probability is a ratio that involves a geometric measure such as length or area. So in the case, like let's say I have an example of a rectangle and then a smaller rectangle. Let's say I told you the larger rectangle, let's say the dimensions are 6 and 8, and let's say it's a square. Let's just say it's 2 and 2. So if I ask you to find what would be the probability of, say, a dart landing in the small square, you would find the area of the square over the area of the whole rectangle. So the area of the square would be 2 times 2. The area of the rectangle would be 6 times 8. And then you simplify the fraction, and it would be 1/12. So this is what we're going to be doing. We're going to be finding the area of the shape we're aiming for over the total area of everything. So let's try. Now, in addition to shapes, we're also going to be finding the probability for line segments. So for here it says, let AB be a segment that contains segment CD. If a point K on AB is chosen at random, then the probability that it is on CD is the ratio of the length of CD to the length of AB. So all this means is the top of the fraction is where we were trying to figure out if the point is going to lie, and we were trying to find out if it was on CD, so this is what we're aiming for, over the whole length of the line segment. So we were aiming for CD to see if point K was on there over the total line segment. Now let's say I said instead, what would be the probability of AC? Then you know that you would put the length of AC over the length of the whole segment. And these would have numbers. So for example, let's say I told you this was 2, let's say this is 5, and let's say this is 4. So if I said, let's find the probability of AC, I would put AC as 2. AB would be 2 plus 5 plus 4, and it would be over 11. Or if I did the one that they wrote right here, CD over AB, well, CD I could find by doing 2 plus 5, it's 7 over the whole thing. Aim is, I'm aiming to figure out if point K is on whatever's in the parentheses, CD. So what I'm aiming for is to see if point K is here. So whatever's in the parentheses after the letter P. That's my aim, where I'm trying to figure out if point K is there. Again, remember, there's 3 ways to write probability. So if it says write your answer as a fraction, we would be done. If it said to express your answer as a decimal or percent, we would have to divide it. Remember, to make a fraction into a decimal, you divide the numerator by the denominator. Now, generally, if it's going to be a repeating decimal like these would turn into, I would leave it a fraction. More than likely, they're going to look for the answer as a fraction.
Did you make up those values or those?
I did. No, I made them up. Okay, now what if I ask you to find the probability of point K landing on AB? What would be that probability? 1 or 100%. Good. Because remember what you're aiming for, which was AB over the whole thing, anything divided by itself is 1 without even knowing any numbers, or 100%. Okay, so now it says let J be a region that contains region M. So we have our, looks like maybe just it's a quadrilateral. So we have 2 quadrilaterals here. So it says if a point K is in J is chosen at random, then the probability that it is in region M is the ratio of the area of M to the ratio of the area of J. So again, they wanted to know the probability that K is going to be in M. So again, they want to know this area. We would have to figure it out. And then this area would be the denominator, the blue. So it would be like the pink over the blue. All right, so here it says, suppose point P on segment AF is picked at random. What is the probability that point P is on segment CF? Now, notice for this one, they didn't give us any numbers along this line segment. However, they did tell us that in between each of the letters, it was the same size. So it told me from A to B is equal to B to C, which is equal to C to D, to DE to EF. So I know that these are all equal. So let's just say that between each one is 1. Okay, so from A to B, it's got 1, B to C is 1, C to D is 1, D to E is 1, E to F is 1. I could have said it had a length of 2. Whatever number I wanted to put on there, just know that the distance between each of those points was the same. So now it's asking me to figure out if point P is on CF. So again, what I'm aiming for is going to be in the parentheses. So CF over the whole line segment. So I need to count how long CF is. So from C to F, it's 1 plus 1 plus 1. It's a length of 3. And then the whole length from A to F is 1, 2, 3, 4, 5. So 3 over 5. If I turn this to a decimal, I'm going to divide 3 by 5. And the answer is 6/10. And then remember, to make a decimal into a percent, you move the decimal point 2 times to the right. So this would be 60%. So they're either going to ask you to express your answer as a fraction, a decimal, or a percent. So next it says, at a carnival game, dishes are positioned on a table so that they do not overlap. So let me go ahead and draw a table here. So here's my table. And then I'm going to put some dishes on my table, and they're not going to overlap. They're just going to be sitting on this table side by side. So let me draw in some dishes. Put some circles on here. They're not overlapping. They're just sitting on the table. It says, you win a prize if you throw a nickel that lands on a dish. If the area of the table is 1.5 meters squared and the combined area of the dishes, so the dishes are all these things, it's saying, what is the probability that the nickel will not land on a dish? So what that means is I want to know the probability of the nickel landing in this blue shaded area. So what we're trying to do here is find the probability of not on a dish. So I need to figure out what is the area of that blue section. I knew the area of the red, the dishes, is 1 meter squared. I know the whole table, red and blue together, is going to be 1.5. So here, we're going to put 1.5 on the bottom. To find the area of just the blue, if the whole area is 1.5 and the dishes are 1, I'm going to subtract, and it's 0.5. It wanted not on the dishes, so the blue. Now, if it said probability of landing on a dish, then I would be doing 1 over 1.5. Now, keep in mind, you can't leave decimal points in a fraction. I need to simplify this. One way you can do it is multiply the numerator and the denominator by the same thing, by 10. Or just move the decimal point the same number of times in the numerator that you do in the denominator. So not on a dish would be 5 over 15 or 1/3. Landing on a dish, and that wasn't the question. The question was the blue. Then I would simplify this and make this 10 over 15, which is 2/3. One way you could check your answer is the probability of an event occurring and not occurring. When you add the two probabilities, it needs to equal 1. Just like when we talk about the weather. If I said today there's a 80% chance of rain, then you know there would be a 20% chance of it not raining, because together it needs to equal 100%. Just like this. So not on the dish would be 1/3, landing on the dish would be 2/3. Now, these are both, if you try to divide them and make them decimals, they're repeating decimals. So generally, if you get a question where when you divide, it's a repeating decimal, chances are they're going to make you leave it a fraction. But one thing you probably should have learned back in middle school when you did decimals to percents or percents to fractions, the percent equivalent for 1/3 is 33 and 1/3%. Because if you divide 1 by 3, you're going to get 0.3 repeating. Now, keep in mind what you can do here is sort of treat it like a mixed number and do like this, and divide it 3, 9, 1, 3, and then stop here, because you would move it 2 times and then take this remainder and put it over what you're dividing by. That's how you can turn it into 33 and 1/3. 2/3 is actually 66 2/3%. But again, more than likely, if it's a repeating decimal, just leave it the fraction. All right. So this example actually has two parts to it. First, it wants us to find the probability that the dart is going to land in the outer circle, which is the blue. And then it also wants us to do the second time we calculate this, what is the probability that it would land in the bullseye? Now, we're going to just leave it in terms of pi. We're not going to use 314. I'm going to do the bullseye first because that's the easier part of this question. So what we're going to do is we're going to find the area of the yellow, which is the bullseye. So area of yellow circle over the entire dartboard, which is going to be the square, over the area of the square. And we're leaving it in terms of pi. So the yellow circle has a radius of 1. The formula for area of a circle is pi r squared. So my answer for the area of the yellow circle is 1 pi, because 1 times 1 is 1. Then the area of the square, it's a 10 by 10, so 10 times 10 is 100. So the probability of a dart landing in the bullseye would be 1 pi over 100. Now, if we were using 314 for pi, we would have put 3.14 over 100 and simplify it. But we're just leaving it in terms of pi. Let's do the harder part. Okay, what it wants me to find is the probability that it's going to land in this section here, this blue. I need to find, again, what I'm aiming for over the entire dartboard. So the denominator is still the square. So I'm going to be doing area of the outer circle over area of the square. Now, my outer circle, it's like the donut. I'm going to be doing area of the whole circle minus area of the yellow. Okay, so I'm going to be doing this whole area here, the whole circle first, and then subtract out the yellow. And then what remains will be the area of that blue or that donut shape. Okay, so notice from here to here is 1, and from here to here is 4. So the radius of my whole circle is 5. So my whole area is going to be pi r squared. So pi times 5 squared, and the whole circle is 25 pi. Then the area of the yellow circle, still pi r squared, but this time my radius is 1. So minus 1 pi. So the area of the blue donut is going to be 24 pi. Now I put it over the area of the square, which again is 10 times 10. So I'm going to do 24 pi over 100, and I need to reduce. I can divide them both by 4, and this becomes 6 pi over 25. Okay, so you're going to complete the homework for 11.4 and turn it into Canvas.